Today we are going to talk about the point which you can see in the screen, that conservative forces can be expressed as negative gradient of potential energy. So let us understand it one by one. So conservative forces, uh, we are going to talk about like gravitational force, that is mg, and spring force kx. Okay, they are conservative forces. They can be expressed as negative gradient of potential energy. Now, what is the meaning of gradient? A gradient means if anything changes with position, is called gradient. Okay, so we'll try to understand. So just like if you go up, that potential energy increases, so this is positive gradient of potential energy. So if I put anything, okay, so let us just understand the meaning of gradient. So if this is ground and you put something, let us say here, so we know that potential energy increases, so this is positive gradient of potential energy. Means if you subtract potential energy here and here, then you will get positive. But as it falls down, as you release it, then you know that this is the direction in which potential energy decreases. So if you take any two values when it is falling and you subtract it, okay, let us say potential energy here and potential energy here, so you will find that as it returns, this change in potential energy will be negative. So that is negative gradient. Okay, now moving on, this thing can be expressed mathematically like this: F is minus du by dr. Now we'll take example to make it clear. Okay, let us take example of this gravitational force, and let us say this distance we are saying is y. Okay, so if the body is here, now this is reference level. If the body is here, we know that potential energy is mgy, right? So what happens, uh, potential energy, I can write it to be mgy. Now r is nothing but the distance. Okay, so in our case it will be y. So if I, you know that m and g are constant, so if I find du by dr, okay, and that is coming out to be mg. Okay, because sorry, if I find du by dy, differentiation of u with respect to y, then I will get mg, right? Now if I put a minus sign here, this is nothing but the force, right? Now, so if I put a minus sign here, minus du by dy, that will be equal to minus mg, right? Now let us try to understand that in a vector way. So according to this point, this is the force, okay, and this force is minus mg. Minus just means that, here the minus sign just means that the force which is mg point in the direction of decrease of potential energy, right? That's why this negative sign comes. So this idea, uh, this formula can be also put into words like force, conservative force points in the direction of decrease of potential energy. Okay, That's why this minus sign comes here. Even if you don't follow this, this idea is enough that the force points towards a decrease of potential energy. Now let us take one more example. Suppose we have a spring force. So let us write. So we all know that spring potential energy is half kx square if it is stretched by x distance, right? So if I find du by dx, okay, the change in potential energy with respect to distance, then this will be half k and this will be 2x. This 2 get cancelled, so this is nothing but kx. Again, if I put a negative sign du by dx, then this will be minus kx. And we all know that minus kx is nothing but spring force, right? So this one I can again write to be F equal to minus du by dx. Now again, I will like to emphasize here on the negative sign that this only means that the spring force points towards decrease of potential energy. That means if I have a spring block system and suppose you stretch it to this length from this point, let us say x equal to 0. So you know that the force will point in this direction, spring force, right? Now you see the direction and potential energy. So as the block comes here, its potential energy will decrease. So this point basically means that the force points, conservative force points along the direction of decrease of potential energy, right? So that's what we mean by this point. Thank you.